Hey Chem Kids, Campbell here. In this video, we're going to talk about the types of chemical reactions because you're going to need to be able to identify them. We're going to talk about 4 different types of reactions. There are some more, but these are the ones you need to know. So we're going to go through each of these in great detail in a couple of minutes, but just as like a little highlight reel, we have a synthesis reaction, which is if we take 2 things and we make 1 thing. A decomposition reaction is the exact opposite. We take 1 thing and we make 2 things. In a single replacement, we have something that's all by itself that takes the place of one of the other ones in the compound. And in a double replacement, I like to call these double doubles because we have a double switch. So everybody switches partners. So let's go into detail. So synthesis reactions, like I said, 2 things combine to form 1 thing. So make sure you write that down. They're also called combination reaction because we're combining stuff. So write down this generic reaction. A plus B yields or produces, right? The arrow means yields or produces AB. So A and B stand for, elements or maybe compounds, but we have 2 things that make 1 thing. A good example of that is if we take sodium metal and we combine it with chlorine gas. That will produce sodium chloride. So I have 2 things and I have 1 thing. So in the reactants, we have 2 things, and in the products, we have 1 thing. Let's go take a look at one in lab. Come on, let's go. So our first reaction is a synthesis reaction. What we're going to do is we're going to take some magnesium solid and we're going to react it with oxygen gas. So here is my magnesium solid. To react with oxygen gas, we're just going to burn it. And whoa, look at that. Wouldn't you know, magnesium sparklers? Cool stuff. And what we've made is magnesium oxide. So we have produced magnesium oxide. Now, magnesium's +2, oxygen's -2, so they just fit together 1 to 1. But you'll notice we're not a balanced reaction now because we had O2 here, we only have 1 O here. So when we balance reactions, remember we put a coefficient in front. But when we do that, that means we have 2 magnesiums. So we got to put a 2 here. So there is our balanced synthesis reaction. Okay, the next is a decomposition reaction. In a decomposition reaction, we have in the reactant side 1 thing, and we produce on the product side 2 things. So our generic reaction is AB, our compound AB, decomposes to produce A plus B. And a good example of this is actually the hydrolysis of water. Now, this actually takes a little bit of energy to happen, but we can actually break water down into its component parts. We can break it down into hydrogen gas, which is super explosive, and oxygen gas. Now, like I said, it takes energy to do this because could you imagine if this happened in nature? Then all the water that we have would be becoming something flammable. That would be hard to sustain life, wouldn't it? So let's take a look at one of these in lab. Come on, let's go. So our next reaction is a decomposition reaction. What we're going to do is we're going to start with some copper carbonate. This must be copper 2 carbonate. And we're going to decompose it by putting it in this flame. So you notice it's in the test tube, so it's not in the flame directly. So it's not like we're reacting with oxygen. Do you notice what's happening to the color? See how it went from a green to a black color. Now, one of the ways we can test what the products of this reaction are is if I take a burning splint, if I start this on fire and I put it in the top, notice that the splint went out. Did you notice also there was some green? Well, that was pretty cool. Let's do it again. So why did the splint go out? Well, when we decompose copper to carbonate, what happens is we get copper oxide plus carbon dioxide. Carbon dioxide, right, puts out fires. So that's why the burning splint went out. The next type of reaction is called a single replacement reaction. In a single replacement reaction, you can tell it's a single replacement because in the reactants you have a single element with a compound, and you produce a compound with a single element, but you'll notice that the single is different than it was before. It's kind of like, you go to a dance by yourself and, maybe there's a couple over there and you actually would prefer that person as your dance partner. So you go over and say, hey, can I cut in? And then you cut in and the other person is out. That's a single replacement reaction. Here's an example. So here's my single, it's lithium. And here's hydrochloric acid, all having fun at the dance. And lithium comes in and says, hey, hydrogen, you're out of here. I want to dance with chlorine. So now you're lithium chloride and hydrogen's all by itself. That is a single replacement reaction. Now, one thing about single replacement reactions is they don't always happen, right? If you go to a dance by yourself, you don't always get the partner. The switch only happens if the single is more reactive than the one that's in the compound. So lithium has to be more reactive than the hydrogen in order for this reaction to happen. We're going to talk more about that in class, but let's take a look at another really exciting single replacement reaction. Come on, let's go to lab. So in our next reaction, we're going to do a single replacement reaction by reacting some zinc with some hydrochloric acid in this test tube. Now look, as soon as I put it in there, we start to see bubbles form. How about we collect that? That means that we're making some gas. Of course, this would be a lot easier if I had a lab partner with me. Let's make sure we get a good seal on that so we can collect some of that gas. So when you have a chemical reaction, right, you can see it with the copper carbonate. We saw the copper carbonate go from green to black. Here we see bubbles forming, which means that we're producing a gas. And so we're collecting some of that gas in this top test tube. Let's see what it is by lighting a splint. And woo! Wasn't that cool? So that means that whatever that gas was, right, that was explosive. Let's see if I can catch it. So what did we do? Well, we took zinc in a single replacement reaction. Zinc replaces the hydrogen, and we get zinc chloride plus hydrogen gas. Hydrogen gas? Hydrogen gas is explosive. So that means, oh, should we balance our reaction? I guess we do. Put a 2 right there. So in a single replacement reaction, hydrogen gas is flammable, and so when we collected it, it exploded. So cool. Our last type of reaction is called the double replacement reaction. I like to call these double doubles because what happens is the atoms are just exchanging between compounds. So you're getting a new partner. So if we take a look, and I'm not sure really what these arrows are about here, but we have AX plus BY. And what's going to happen is A is going to go with Y and B is going to go with X. So I have AY as a product and I have BX as a product. So it's like a switcheroo. I kind of think of it like, if you're square dancing. In square dancing, you're dozy-doing with your partner, and then all of a sudden you have to switch partners, and now you're with the other partner. So square dancing are double replacement reactions. Everybody wins, everybody just gets a new partner. Now, for this reaction to happen, both of the compounds in the reactants have to be soluble. We're going to talk more about how to figuring out if something is soluble in class, but in order for this reaction to happen, everybody has to dissolve in water. They have to be aqueous. Now, the trading of partners only happens if something becomes a solid, a gas, or a product is water. So write that down. This reaction only happens, this trading only happens if one of the products, or both, become solids, they're gases, or water is produced. Otherwise, no reaction happens. We're going to, again, learn more about that in class. But here's an example. Silver nitrate and sodium chloride, notice that they're aqueous, which means they dissolved in water. They react to produce silver chloride, which is a solid, so that meets my solid requirement, plus sodium nitrate. So this reaction happens. Let's look at another one that happens. Let's go. So in our last reaction, we're going to do a double replacement reaction where we're going to take some zinc acetate, which is nice and clear here in this test tube, and we're going to add some sodium phosphate, which is also clear. Whoa, look at that. It was clear. Now it's cloudy. What that means is we formed a precipitate, a solid. So what did we form? Well, in a double replacement reaction, zinc and sodium are going to switch places. So we're going to have products of zinc phosphate and sodium acetate. Sodium acetate is soluble, but this is insoluble. It forms a solid, and that's what we saw, that white substance. All right, take a look at these 4 reactions and see if you can figure out which is which. Pause the video and see if you can identify them. Well, did you say that the first one was single replacement? If you did, you're correct. Right here's my single, and it replaces one in the double. It replaces the silver. The second one, that's a double-double, a double replacement reaction. The third one, decomposition. We have 1 that goes to 2, and that leaves number 4 to be synthesis. 2 goes to 1. How'd you do? Well, there's an assignment for you to do in Canvas, so do that to check your learning, and I'll see you in class tomorrow.